14 questions have been set from the chapter Complex Numbers in the JEE Main examinations held in the January 2024 session. In earlier two videos, we have discussed the 10 questions, the first 10 questions. We now discuss the question number 11 to 14, that is 4 questions in this video in detail. This question has appeared in the JEE Main exam held on 31st January 2024 in the second shift. The given question is, let Z1 and Z2 be two complex numbers such that Z1 plus Z2 is equal to 5 and Z1 cube plus Z2 cube is equal to 20 plus 15i, then modulus of Z1 to the power of 4 plus Z2 to the power of 4 equals, we are given 4 options. And we are given Z1, Z2 are complex numbers such that Z1 plus Z2 is 5, Z1 cube plus Z2 cube is 20 plus 15i. Required to find the value of modulus of Z1 to the power of 4 plus Z2 to the power of 4 from the given 4 options. Let's now discuss the solution of the problem in detail. We have Z1, Z2 are complex numbers, belongs to C, the set of complex numbers. Given Z1 plus Z2 is 5, Z1 cube plus Z2 cube is equal to 20 plus 15i. So, from this we will find Z1, Z2, the product Z1, Z2. 20 plus 15i is equal to Z1 cube plus Z2 cube, A cube plus B cube. So, we write it as Z1 plus Z2 whole cube minus 3Z1 Z2 multiplied by Z1 plus Z2. Yes. So, in this Z1 plus Z2 is 5 cube minus 3Z1 Z2 multiplied by 5. That is 5 cube is 125 minus 15 Z1 Z2. What we want is Z1 Z2. So, 15 Z1 Z2 is equal to 20, 125 minus 20, 105 minus 15i. 15 Z1 Z2 has gone the other side. So, 15 Z1 Z2 is equal to 105 minus 15i. So, cancel 15 throughout, we get Z1 Z2 is equal to 7 minus I. Now, the plan is to find Z1 to the power of 4 plus Z2 to the power of 4. First, we will find Z1 square plus Z2 square. So, now Z1 square plus Z2 square is equal to Z1 plus Z2 whole square minus 2 times Z1 Z2. So, this is 5 square minus 2 times Z1 Z2 is 7 minus I. Simplify, we will get 11 plus 2i. So, Z1 square plus Z2 square is 11 plus 2i. From this, we compute Z1 to the power of 4 plus Z2 to the power of 4. So, Z1 to the power of 4 plus Z2 to the power of 4 is equal to Z1 square plus Z2 square whole square minus 2 Z1 square Z2 square. And we know Z1 square plus Z2 square, that is 11 plus 2i whole square minus 2 times 7 minus I whole square. Why? Because Z1 Z2 is 7 minus I. We want Z1 square Z2 square. Therefore, it is 7 minus I whole square. So, 11 plus 2i whole square, it is 117 plus 44i. This is 11 square 121 plus 2i whole square is minus 4. So, 121 minus 4 is 117. plus 2 times 11 into 2i is 44i. So like that. So minus 2 times 7 minus I whole square is 48 minus 14i. Simplifying, we'll get 21 plus 72i. So what's that we want? The modulus of z1 to the power of 4 plus z2 to the power of 4 we want. So the modulus of 21 plus 72i, that is under the square root of 21 square plus 72 square, that is under the square root of 441 plus 72 square is 5184, that is under the square root of, on addition you will get 5625. It is a perfect square and it is 75 square. Therefore under the square root of 5625 is 75. So let's look at our options. So our answer 75 appears against option 2. Therefore the answer to this question is option 2. That is the detailed discussion of the solution of this problem, and it is a very simple, straightforward question. I am sure that you have understood the solution of this one. We will now move on to the next question. This question has appeared in the JEE Main exam held on 1st February 2024 in the first shift. Let capital P be the set of Z belongs to C such that modulus of Z plus 2 minus 3i is less than or equal to 1, and Q is the set of all Z belongs to C such that Z into 1 plus I plus Z bar into 1 minus I is less than or equal to minus 8. Now let in P intersection Q, mod of Z minus 3 plus 2i be maximum and minimum at Z1 and Z2. We better read this sentence as modulus of let modulus of Z minus 3 plus 2i be maximum and minimum at Z1 and Z2 in P intersection Q. So that's better. That's better. So respectively, their maximum and minimum respectively. So if mod Z1 square plus 2 times mod Z2 square is equal to alpha plus beta times root 2, where alpha beta are integers, then alpha plus beta equals, we are given P like this, Q like this, and you are given the maximum and minimum of modulus of Z minus 3 plus 2i in P intersection Q. Let the maximum minimum will be Z1 and Z2 respectively, and given mod Z1 square plus 2 times mod Z2 square is equal to alpha plus beta root 2, where alpha beta are integers, required to find the value of alpha plus beta. Okay, let's now discuss the solution of the problem in detail. We have P, the set of all Z belongs to C, such that modulus of Z plus 2 minus 3i less than or equal to 1. So let's write down for Z x plus iy, where x, y are real numbers. So x plus iy such that modulus of x plus iy plus 2 minus 3i, that is modulus of x plus 2 plus I times I multiplied by y minus 3, modulus less than or equal to 1, where x, y belongs to R. So this is the set of all those ordered pairs x comma y belongs to R square, such that this modulus square we have written here, x plus 2 square plus y minus 3 whole square less than or equal to 1. Yes. So that is P is the set of all points x comma y which lie inside, because less than, and on, because it is equal to, the circle C x plus 2 whole square plus y minus 3 whole square is equal to 1. What is this? It is a circle with the center at minus 2 comma 3 and a radius 1. And what is P? P is the set of all those ordered pairs x comma y belongs to R square. That is the set of all points which lie inside and on this circle, because it is less than or equal to. Agreed. This is your diagram. So this is minus 2 comma 3 and the radius is 1. Agreed. We have Q given to be Z belongs to C, such that Z into 1 plus I plus Z bar into 1 minus I is less than or equal to minus 8. It may be observed that this must be a straight line. If it is equal, it is a straight line. So write Z is equal to x plus iy, where xy belongs to real numbers. X plus iy, x plus z is x plus iy multiplied by 1 plus I plus z bar complex conjugate, that is x minus iy multiplied by 1 minus I less than or equal to minus 8, where x and y are real numbers. Agreed. Now this is the set of all those ordered pairs x comma y belongs to R square, such that x plus iy into 1 plus I plus x minus iy into 1 minus I less than or equal to minus 8. Right. Simplify. Now simplify. It is the set of all ordered pairs x comma y belongs to R square. On simplification, we will get a 2x minus 2y is less than or equal to minus 8. Cancel 2 throughout. So that is the set of all those ordered pairs x comma y belongs to R square. X minus y is less than or equal to minus 4. X minus y is equal to 4 is a straight line. It's a straight line. X minus y less than minus 4 will be all those points which lie above the line x minus y is equal to 4. So that is Q is the set of all points which lie above and on the line L1, let's call that line as L1, x minus y is equal to minus 4. So let's look at the picture. Let's look at the diagram. So then P intersection Q is common to that circle and this is straight line. All those ordered pairs. So the mixed shaded depicts P intersection Q. So the mixed shaded, this is a brick red color, this is blue color, and the mixed brick red and blue color is this one, above this line. How do you say x minus y less than minus 4 will be all those points which lie above this line? For that, the simple test is you take this center of the circle minus 2 comma 3. Now substitute in L1 minus 2 plus 3. So it is minus 2 plus 3 minus 5. Minus 5 is less than minus 4. So it satisfies. Therefore, this is the region. That means the above this line and on the line will be Q. So the mixed shaded depicts P intersection Q. That's the first part. Let's continue in the next slide. So that's what we have so far. The circles equation is here, L1 line equation is here, and the P intersection Q is the mixed shaded portion. Let R, so let us take the R is the set of all those modulus of Z minus 3 plus 2I, where Z belongs to P intersection Q. That means so it is a Z minus in brackets 3 minus 2I. That means 3 minus 2I is a point. 3 minus 2I is a point in the fourth quadrant. And that and all those Z belongs to this mixed shaded portion. The distance between all those Z to 3 minus 2I. For that, the maximum and minimum you have to find out. So for that, we write Z is equal to x plus iy. So this will be x minus 3 plus I times y plus 2. So that will be under the modulus, means under the square root of x minus 3 square plus y plus 2 square. Xy belongs to P intersection Q. It is not a circle. It is a length. It is a length of the line segment joining 3 comma minus 2 to any point in the P intersection Q. Right. So now, given Z1 is the maximum of R1, maximum of this R, the maximum of R1. So maximum of all those lengths, So let L2 be the line joining minus 2 comma 3, that is the center of the circle, 2, and the point 3 comma minus 2. So this is 3 comma minus 2 is somewhere here. This is L2 joining the center of the circle and intersecting the circle at this point. Now, what will be the maximum? What will the maximum distance? The maximum distance is this one. So the maximum is attained at this point. So let that is L2. What is the line? The line joining minus 2, 3 and 3 comma minus 2. 2-point formula you apply and get me the equation of the line. That is L2 is x plus y minus 1. We are leaving some portions of it. Right. So this is the straight line. And it may be seen Z1. What is Z1? It is given Z1 is to be the maximum of R. So Z1 is what? Z1 is this one. That is the maximum of this distance. And that is the point of intersection of this line L2 and the circle C. So you take L2 equation and the circle equation and solve and find out the points of intersection. For your convenience, I have shown you in this snippet. So L2 is y is equal to 1 minus x, and the circle C is x plus 2 whole square plus y minus 3 whole square is equal to 1. So for y, you substitute 1 minus x and simplify. You will get 2 times x plus 2 whole square is equal to 1. That will be x plus 2 is equal to plus or minus 1 by root 2. And x will be minus 2 plus or minus 1 by root 2. So what are these? These are the x coordinates of this point and this point. And the x coordinate of Z1 is minus 2 minus 1 by root 2. So x is minus 2 minus 1 by root 2. I have asked you why. Why? Because it is minus 2 minus 1 by root 2 is away from the y-axis. Minus 2 plus 1 by root 2 is nearer to y-axis. So minus 2 plus 1 by root 2 will be here, somewhere here. So corresponding to this one, what is y? So y is equal to, in this you substitute 1 minus, in brackets, minus 2 minus 1 by root 2, that is 3 plus 1 by root 2. So these are the coordinates of this point Z1. So this is minus 2 minus 1 by root 2, 3 plus 1 by root 2. That is your Z1. So what is Z2? Z2 is the minimum of R. R is the shaded portion. The minimum length is this one. This is the minimum R. So that is what minimum of R is this point Z2. What is this? It is the point of intersection of L1 and L2. So the point of intersection of L1 and L2. Now L1 is x minus y is equal to minus 4. L2 is x plus y is equal to minus 1 is equal to 0. And two equations, two unknowns. So it's very easy to find out the point of intersection. Solve these two equations and you will get minus 3 by 2 comma 5 by 2. I am leaving it to you. Agreed. So thus we got Z1 the maximum, Z2 the minimum we got. Now given alpha plus beta root 2 is equal to mod Z1 square plus 2 times mod Z2 square. So what will be mod Z1 square? That is the square of this x coordinate plus the square of this y coordinate plus 2 times the square of minus 3 by 2 plus the square of 5 by 2. So that is square plus 2 times minus 3 by 2 whole square plus 5 by 2 whole square. This is mod Z1 square, 2 times mod Z2 square. And simplify, you will get 31 plus 5 root 2, and that is given to be alpha plus beta root 2. On comparison, you will find alpha is equal to 31, beta is equal to 5. So required to find the value of alpha plus beta, and that will be 31 plus 5, that is 36. So the answer to this question is alpha plus beta is equal to 36, and we move to the next question. This question has appeared in the JEE main exam held on 1st February 2024 in the first shift. The given question is, let S be the set of all Z belongs to C such that modulus of Z minus 1 is equal to 1 and root 2 minus 1 in brackets multiplied by Z plus Z bar minus I times Z minus Z bar is equal to 2 root 2. Let Z1, Z2 belongs to S be such that mod Z1 is the maximum of mod Z, where the maximum is to be taken over all those Z belongs to S, and mod Z2 is the minimum of mod Z, where the minimum is to be taken over all Z belongs to S. Then modulus of root 2 times Z1 minus Z2 whole square equals to, we are given 4 options. So we are given, yes, the set of all those complex numbers Z belongs to C such that mod Z minus 1 is equal to 1, it is a circle, and root 2 minus 1 multiplied by Z plus Z bar minus I times Z minus Z bar is equal to 2 root 2. It is a straight line. And let Z1, Z2 belongs to S such that mod Z1 is the maximum of all those mod Z, where Z belongs to S. Mod Z2 is equal to minimum of mod Z, where Z belongs to S. Required to find modulus of root 2 Z1 minus Z2 square equals. Let's now discuss the solution of the problem in detail. We have the given set S. So in this, first we consider modulus of Z minus 1 is equal to 1. Let us take a Z is equal to X plus IY, substitute in this. You will get this one is mod of X minus 1 plus IY is equal to 1. So this is on squaring on both sides, you will get X minus 1 whole square plus Y square is equal to 1. Let's call this as the equation 1, which is a circle. Right. Now take the other equation, root 2 minus 1 multiplied by Z plus Z bar minus I into Z minus Z bar is equal to 2 root 2. Z bar is X minus IY, Z is X plus IY, Z plus Z bar is twice the real part, that is 2 times X. And Z minus Z bar will be 2IY. 2IY. Right. So substitute root 2 minus 1 into 2x minus I into 2IY is equal to 2 root 2. 2 cancels. I into IY is minus Y minus, there is another minus here, plus Y. So this is root 2 minus 1 multiplied by X plus Y is equal to root 2, and Y is equal to root 2 minus 1 multiplied by X. Let's call this as the equation 2, which is obviously a straight line. And S is what? S is this set of all those points of intersection of the circle and this straight line. This straight line. Clearly, S is the set of points of intersection of the circle 1 and the straight line 2. Let's find out what are the points of intersection. So we now find the points of intersection. We do it in the next slide. Yes, that's what we have. Right. Now 1 implies, 1 means y is equal to root 2 minus 1 multiplied by x. That value of y you substitute in the equation of the circle. So x minus 1 whole square plus y square. Y square is root 2 minus 1 times x whole square is equal to 1. Now simplify. Further simplification, you do it and simplify further, you will get this one. This will imply at the end you will get 4 minus 2 root 2 times x square plus 2 root 2 minus 6 times x plus 2. Still further simplification. 2 root 2 times x square minus 3 minus root 2 x plus 1 is equal to 0. Yeah, factorization we have done. 2 minus root 2 times x minus 1 multiplied by x minus 1 is equal to 0. 1 is obviously a root of it. That's the clue. Right. And the roots are x is equal to 1 and x is equal to 1 by 2 minus root 2. That is equal to 1 by root 2 take common, root 2 multiplied by root 2 minus 1. Now rationalize, you get root 2 plus 1 by root 2, that is 1 plus 1 by root 2. Agreed. X is equal to 1 and x is equal to this. Right. So x is equal to 1 and x is equal to 1 plus 1 by root 2. So let us take x is equal to 1. From the straight line equation, put x is equal to 1. Then y value will be 1. Put the other value of x. Then the y value is 1 by root 2. 1 by root 2. So what are the points of intersection? That means this circle and this straight line, they are intersecting at 2 points. And what is S? S is the set of points of intersection of the circle 1 and straight line 2. That means S precisely contains only 2 points. S is x plus iy belongs to C, where x comma y is 1 comma 1 and x comma y is 1 plus 1 by root 2 comma 1 by root 2. Right. So these are the, so this is 1 comma 1 means 1 plus I, and this is 1 plus 1 by root 2 real part plus I by root 2 as complex number. So that means S has only 2 points. And obviously one will have the maximum modulus and the other will have the minimum modulus. Right. So take the modulus. Mod Z, Z belongs to S. Mod of 1 plus I, comma, mod of the second one, 1 plus 1 by root 2 plus I by root 2. When you take the mod of 1 plus I, root 2, mod of this one is this one. Simplify. This is root 2, comma, under the square root of 2 plus root 2. Which is bigger? This is bigger. This is bigger. This is bigger. So which will have maximum modulus? So this will have maximum modulus. So given Z1 is the maximum of mod Z. That is, the maximum of mod Z is under the square root of 2 plus root 2. So what will be Z1? Z1 will be this one. 1 plus 1 by root 2 plus I by root 2. Mod Z2 is the minimum of mod Z, that is root 2. Root 2 means 1 plus I. So Z2 is 1 plus I. Now required to find mod of root 2 Z1 minus Z2 square. So take that. So mod of root 2 z1 is 1 plus 1 by root 2 plus I by root 2 minus z2 1 plus I mod square. Simplify. You will get this, after cancellations you will get mod of root 2 square, that is 2. That is 2. So let's look at our options. Our answer 2 appears against option 3. Therefore, the answer to this question is option 3. And it is definitely a little difficult question. And the competitions are more also. I am sure that you have understood the solution of this problem. And we move on to the next problem. That is the last problem in this video. This question has appeared in the JEE main exam held on 1st February 2024 in the second shift. If z is a complex number such that mod z greater than or equal to 1, then the minimum value of mod of z plus 1 by 2 multiplied by 3 plus 4i, mod of that is, we are given 4 options. So z is a complex number such that mod z greater than or equal to 1. What is this? It is the set of all those points which are outside and on the circle mod z is equal to 1. That is, the exterior of the circle mod z is equal to 1 and all the points that lie on the circle mod z is equal to 1. And then you have to find out the minimum value of mod of z plus 1 by 2 multiplied by 3 plus 4i. Agreed. That's the given question. Let's now discuss the solution of the problem in detail. Let S be the set of all those complex numbers z such that mod z greater than or equal to 1. What is this? It is, S consists of all points which lie outside because mod z greater than 1 and on the circle because mod z is equal to 1. The circle is mod z is equal to 1, that is x square plus y square is equal to 1. That means all the points which are the exterior of the circle mod z is equal to 1 and including the points on the circle. The representation is here. So this is the unit circle and all points lie outside and on the mod z is equal to 1. Agreed. Now required to find the minimum of modulus of z plus 1 by 2 multiplied by 3 plus 4i. This where the minimum is to be taken over all z belongs to S. That means all z belongs to the points which are the exterior of mod z is equal to 1 and including the points on the circle. So that is equal to, this is same as the minimum of mod of z minus in brackets minus 3 by 2 minus 2i, where the minimum is to be taken over all z belongs to S. What is this? It is, the z is a variable point in S and minus 3 by 2 minus 2i is a fixed point, and z minus this fixed point mod of that is the distance of this fixed point from the various points of z belongs to S. Out of all that, those distances, you have to take the minimum. So that is the one. Notice that this point minus 3 by 2 minus 2i, the modulus of that is equal to under the square root of minus 3 by 2 whole square plus minus 2 whole square. That is equal to 5 by 2, which is greater than or equal to 1. greater than or equal to 1. So that means this point minus 3 by 2 minus 2i belongs to S, will lie in the exterior of that. So let's look at the picture. This is the point. Minus 3 by 2 minus 2i belongs to S. Now, what is the minimum of this modulus over Z, where the minimum is to be taken over all Z belongs to S? So it will be 0. It will be 0. So the minimum of Z belongs to S, modulus of Z plus 1 by 2 times 3 plus 4i is 0. So now, unfortunately, our answer 0 does not appear in the given options. So is the question dropped? I think so. Okay. Suppose I wanted to save this question thinking that there is a printing problem. That means instead of mod Z greater than or equal to 1, I will take mod Z less than or equal to 1. So if we take mod Z less than or equal to 1 instead of mod Z greater than or equal to 1, then the answer would be 3 by 2, which appears one among the options. So I leave it as a homework to you. Do it. So the same question, instead of mod Z greater than or equal to 1, you take mod Z less than or equal to 1, the same question, then you will get the answer 3 by 2. This is just to save the question. So that is the detailed discussion of this question, and we have come to the end of the discussion of the 4 questions that are meant for the discussion further in this video that we have done it, and I am sure that you have understood all these 4 questions, and I wish you all the best. Thank you.